Welcome to the presentation of the Token Electronic Signature project developed in Mirandola plant. We hope that this presentation might arouse your interest in this project. We hope that this presentation is clear enough, and you will enjoy it. Needs. What are the needs that led us to the development of this project? The choice. Why did we choose this type of hardware? Challenging issues. What are the problems we met along the way? Costs. What have the major costs for the software development been? Asymmetric keys. Few words on what the asymmetric keys are and how they work. Validation. How we have performed the validation. Software workflow. Software functioning. Software used. With what have we developed the product of this presentation? On what applications this project impacts. List of the applications on which this product has got an impact and on which we intend to apply it. The bricks of the infrastructure. Our needs were mainly: make the records in different databases unmodifiable. Electronically signature of the records. An easy-to-use tool for the electronic signature. Sure, we could have used the tools that the corporate provides us with, i.e. the use of a secret password. But we all know that the login PW is not always as secret and safe as it should be. Thus we have investigated several alternative tools, e.g. fingerprints or retina reading. Thinking of the different uses that the perfect secure tool would be devoted to in Mirandola plant, e.g. use in the clean or other production rooms where hands can be dirty, or covered by gloves, we deemed that the token would have been the most suitable one. The token is a peripheric USB, just like the USB keys to save data, thus very easy and intuitive to use. All tokens are only one use, i.e. once a username is imprinted on it, it is indelible, unless the token is destroyed, which of course make it no longer usable. Each token is quite expensive, but considering that it may be used on different applications, the initial cost will be quickly compensated. Once the obstacle of the library is in the SDK, utility for the programming made available by Vesco, written in C++, is bypassed. Developing the whole application required only 5 months per worker, including also the reading part by means of the utilities made available by the OpenSSL. The partners of this project gave us all the necessary support in the development of the application. Like all the projects, we have met several issues, especially the interpretation of the SDK libraries that, as we said, are written in C++. This took us some amount of time and resources to be able to write to DLL that could make the tokens work as needed. In fact, we need to use tokens both in web and in client-server environments, the latter being sure easier than the former. Thus, we developed the application for the physical management of tokens, and we wrote an OCS and a JavaScript able to read the tokens in the USB ports of the clients. Another issue has been the validation. Unfortunately, in Italy this kind of activity is not commonly performed, so the software validation has taken some time to the team. Last but not least, the possibility to check the signed fields/records without physically accessing to the token used for the signature itself. This issue can be met in case a user loses or breaks the token, or to check afterwards that the atomic record saves the record. The solution here has been the installation of an OpenSSL. Using this setting and the public key of the tokens on the base, we are always able to control that the records are not modified. Basically, all costs can be grouped in 3 major expenses. Purchase of tokens, near €65 each. Development, near €8,000. Validation, near 60 days per worker. The theoretical functioning of the asymmetric keys is simple. For a correct process of the electronic signature, 2 keys are necessary, a public and a private one. A document is signed by means of the private key. The user or the program will distribute the public key to those who need it. Once the crypted field is known, with the public key it is possible to check whether this has been modified or not. If changes are made, the OpenSSL can detect them. The field cannot be decrypted, so obviously it is not possible to know exactly what change has been done. In our specific case, the field used to create the MD5. The MD5 is indeed the first cryptography of the data, are known because we have put them in the database. The string containing the MD5 is transferred to the token which signs it with the public key. Then our software makes a scanning of all our records digitally signed, recreating the MD5 field and evaluating in this very step if the fields have been modified or not. If they turn out to be correct, the software by means of the stored public key will transfer to the OpenSSL the MD5 field just recreated, along with the coded field and the public key. If everything is correct, the application will proceed to the next field. We deemed necessary to proceed with the validation of this software, because the tokens will be used in several applications inside the plant. This obliges us to meet the FDA CFR 21 and Part 11 requirements. Considering the peculiarity of the application, the team who developed it is the same who made the tests. In order to complete the software, we had to use several development environments. C++ necessary to create the DLL to examine the token, as well as to implement the control of the signatures after they are done by means of the OpenSSL. Visual Basic 6 for the creation of the OCX, necessary for the interfacing of the token client side in the web-based applications. JavaScript to run the OCX. C# for the development of the entire application and the interfacing with the database. To support the software, some servers have been necessary. A web application server equipped with IS to publish the application. A RESQL 2005 server to save data on. A file server to share the DLL. Besides, several additional clients, in order to use the token on as many applications as possible. At the moment, the application involved in the use of the tokens are the SPC, where we use the token to eliminate the signature of the documents concerning the production measures, the applications to input the PPK, and for the signature of all the modules to access to the web/internet/new user. This last slide has got the workflow of the application currently used. Thanks a lot for your attention.